Good evening. I welcome you all for this machine learning course, session 1. So first of all, let's understand what is machine learning. Okay. So machine learning is humans' knowledge is only obtained by experience throughout their life, and for machines, those knowledge need to be fed by collecting enormous amount of data and certain applications and fed to it. Okay. So what they are coming to say from this definition is, for example, when you look at a dog or cat, you are immediately identifying it's a dog or it's a cat. Okay. So how you are going to how you are able to identify whether it's a cat or dog. Okay. So it has some features to identify whether it's a dog or cat. So how do you got that information? Okay, your brain is able to identify whether it is a cat or dog, so based upon some information which has been already fed to the brain. Okay, so who gave that information? That information may be given by maybe your parents or by your teacher or someone who is known to you. Okay, so our brain is already trained with the enormous amount of data, so that when you look at a new variety of dog or new variety of cat also, you are able to identify it's a dog or cat. Okay, the same thing we are going to do with the machines also. Okay, so what you are going to do is, we already have enormous amount of information. We are going to feed this information to the machine, and we are going to train the machine so that the machines will start identifying whether it's a dog or cat. Okay, so that is the way the machine learning happens. Okay, so whatever happening in our human, the same thing we are trying to mimic with the machines also. Okay, so that is what the knowledge that's what the definition given here. Humans knowledge is only obtained by the experience throughout their life. Okay, so for the machines, how that experience is going to be happen is, that is through the data that has been, that you are going to feed it to the machine. Okay, so for that you need enormous amount of data. You cannot feed only 5 data or 10 data or hundreds of data, and you can't train the machine. Okay, you need thousands and thousands of data, so that you can train the machine with thousands of data, so that the machines can easily identify what kind of data it is, what kind of animal it is, whatever it may be. Okay, so that is what actually machine learning is called. So machines also obtains the knowledge in a short period of time. Okay, so for humans it takes much time to identify something, because the experience, as you will have to gain the experience throughout your lifetime. Okay, from the childhood onwards we have been trained on many things. Okay, but if you want to train a machine, it will happen within a fraction of seconds, or it may be a 1 hour or 2 hours. Okay, within that time you can train the machines if you have enough data. Okay, so that is what you can train the machines in a short period of time. Okay, so that is what actually called machine learning is. So there are 3 types of machine learning available. One is supervised, unsupervised, and then reinforcement learning. These are the basic types of machine learning. Let's see one by one. So what do you mean by supervised learning? So in the supervised learning, we are going to supply the input data as well as the labels. Okay, here in between you have something called AI model. We are going to supply it to the AI model the data as well as the labels. Okay, you can see here, this is the inputs. Okay, and this is the labels labeled. These are apples and these are bananas. Okay, so I am going to give one apple image, and I am going to tell the machine that is it is an apple. I am going to give one banana image, and I am going to tell the model that this is an banana. Okay, so that is how this AI model has been trained. Okay, so this is what actually called as machine. Okay, so the machine is learning from these inputs. The inputs are the images as well as the labels. Okay, so next time, once the model is trained, next time when you give a new image of an apple or banana, then it is able to identify or predict whether it is an apple or banana. Okay, so this is what happening in supervised model, supervised learning. The next model we have is, I'll come to this later. The next model we have is unsupervised learning. So in unsupervised learning, what is happening is, there are no labels here, only the images will be supplied. As you can see here, the apple image is there and banana images are there. Okay, both are mixed. Okay, but there is no labels. Okay, so these images will be fed to the machine. So the machine will start identifying some similar features between the images. Okay, for example, if you say an apple, the apple is having somewhat circle in shape and then red in color. So these are all some features of an apple. And similarly for banana, it's yellow in color and some oval shape, something like that. Okay, so based on these features, the machine itself started grouping the data. Okay, so the fruit which is having these similar features will be identified as group 1. Okay, and the another fruit which is having these kind of similar features, which is identified as group 2. Okay, so like this, here there is a kind of classification or grouping or clustering will happen here. Okay, so here it will not identify whether it is an apple or banana because there is no labels given, but it is able to group the fruits into a fruit 1, fruit 2. Okay, or group 1, group 2, something like that. Okay, it is able to identify the groups alone. It will not be able to identify what kind of fruit it is. Okay, because you have not given the inputs, you have not given the labels. Okay, so that is called unsupervised learning. You supply the data, based upon some features, it will automatically categorize the data into different groups. Okay, so that is called unsupervised learning. So for unsupervised learning, the example is clustering. Okay, clustering algorithm. As you can see from here, there are different data available. Okay, so each data is of different types. For example, you can see here star is there, diamond and circle. Okay, 3 different kinds of data is there. So based on the structure of the data and maybe structure of the images, it is going to group. This is one group and this is second group and this is third group. Okay, something like that. This is called clustering, which comes under unsupervised learning. Okay, in supervised learning, there are 2 kinds of problems. Mostly not only in supervised learning, in machine learning itself, basically there are 2 kinds of problems. One is classification, the another one is you will call it as prediction or regression. Okay, so classification is nothing but we are going to classify whether the data is data belongs to class 1 or class 2, or yes or no, or true or false. It is something like that. Okay, so you are going to do a classification on the data based upon some inputs. Okay, so that is called classification. And in prediction or regression, what is happening is we are going to find out some value. Okay, we are going to calculate some value. Okay, it means that for example, I can tell you like the price of this house is for example today 20 lakhs. What will be the price of this same house after 20 years or after 30 years? Okay, so that kind of prediction you can do it. Okay, or the revenue of this company is maybe 10 lakhs. What will be the revenue of the same company after 20 years or after 2 years or after 5 years, something like that. So that kind of calculation you can do it. Okay, so that kind of problems will come under prediction or regression. Okay, so basically there are only two kinds of problems. Either you do the classification, you find out the class whether it belongs to this class or that class or that class. There may be any n number of classes also. Okay, so that is classification. The other kind of problem is you find out the value of the given item. Okay, that is called prediction or regression. Okay, you are going to predict the price of that item after some years or whatever it is. Okay, depends upon the problem. Okay. So that is under supervised learning, and unsupervised learning you have clustering. Okay, this one we have discussed already. And the third type of machine learning is reinforcement learning. Okay, so in reinforcement learning everything happens in terms of rewards and punishment. Okay, so this is a maze given here. Okay, so if you look at this maze, this is an entry point. Okay, so I have to enter here and I have to come out here. Okay, imagine. Okay, now when I move into this maze, what's happening is I am trying to move towards this side. I am finding that there is no way. Okay, then I have to come back this side and I have to try another path. Okay, so like this, when I go and hit this dead end, it means that it's a negative reward, or I can call it as it's a punishment. Okay, I will get -1 point, something like that. Okay, so whenever the machine gets a -1 point or negative reward, the machine starts learning. Okay, so this is not the right way of going into the maze to find out the solution. Okay, similarly, if any problem is given, it will try to solve the problem in one direction. It will try to solve the problem in one direction. If the machine is not able to solve the problem in one direction, then it will get a negative reward. Okay, it will start identifying the wrong way of doing the solutions to the problem. Okay, so from that experience the machine starts learning. So if you give similar kind of problem next time, what the machine will do is the machine will not do in the same way whatever it has done previously, because it has got some negative reward. Okay, then what the machine will do is the next time if you give a similar kind of maze, it will not go this way, then it will take another way and it will try out the solution in different way. Okay, so if you go in the right direction, you will get a positive reward. If you go in the wrong direction, you will get a negative reward. Okay, so by getting these rewards, the machine itself starts learning which is correct and which is not correct. Okay, so from this learning, the machine will gain some knowledge, and whenever you give similar kind of problem next time, what will happen? The machine will go in the right direction so that it will solve the problem. Okay, so this is called actually a reinforcement learning. So this is the basic three kinds of problem we have. Okay, and the basic machine learning process goes like this. These are the steps involved in machine learning process. The first step is gathering the data. Gathering the data is just collect the required data, whatever required to train the machine. Okay, the next one, preparing the data. Once you collected the data, you need to prepare the data. You cannot feed the data directly to the machine. Preparing the data is nothing but doing some kind of basic cleaning. Okay, cleaning is like removing the null values and removing some wrong data, correcting some formats in the data. If there is any duplicates, eliminate the duplicates. So these are all the things we can do in preparing the data. It is otherwise called as pre-processing the data. Okay, now once the data is ready, you will have to choose the model. Okay, so model in the sense there are different kinds of problem. I told you, classification problem is there, regression problem is there. Okay, so based upon the problem, you will have to identify which algorithm is suitable for solving this problem. Okay, so that is called choosing a model. Okay, so once the model is chosen, then you need to train the model. Okay, so training will happen with the data whatever you have prepared. Okay, you have prepared and kept some data, right? So with that data the training will happen. Okay, now after the training you need to do the evaluation, that is you need to test the model. Okay, so for that you need to give some data and you will have to test the model. Okay, actually for training and evaluation the data will be splitted. For example, if there are 100 data, 80% of the data will be used for training and 20% of the data will be used for testing. Okay, evaluation mostly, or it may be 70-30, or it may be even sometimes 60-40 also. Mostly they will use 80-20. Okay, then after testing, that is evaluation, you can go for hyperparameter tuning. Okay, so when you are doing the testing, in case if you find any discrepancy, for example, if the machine is not able to perform properly, okay, the machine is not able to identify properly, if the machine is not getting the expected accuracy, then you need to tune the model. Tune the model in the sense you will have to adjust some parameters in the model. Okay, so these kind of adjustments will be done automatically by the algorithm. Okay, you no need to do anything. That will, you need to supply some initial values. Okay, and the algorithm itself will do the tuning. Okay, now after this tuning happens, the model will be ready. Okay, after the tuning again you will have to do training evaluation. Once you get the expected accuracy, then the model will be ready. Once the model is ready, then you can start doing the classification or prediction. Okay, depends upon the problem whatever you want to do. Okay, you can supply some new data and you can identify the class, or you can supply some new data and you can get the predicted value. Okay, prediction. Okay, so this is what the machine learning process we will follow usually in all machine learning problems. Okay, okay, so these are all some of the applications of machine learning. So as you can see here, we'll start with this one, first one, medical diagnosis. Okay, medical diagnosis in the sense, for example, if you take some medical images, like you'll have CT scan, MRI scan. Okay, so already we have images of a lot of patients. Okay, so these images will be fed to the machine learning model, and the model will learn from the images whatever given to the machine. Okay, and the machine will start identifying what kind of diseases from the image itself. Okay, for example, if you are feeding MRI image of a patient who is having a brain tumor, okay, then we will be giving to the machine which image is having tumor and which image is not having tumor. Okay, we will be label the images and we will be giving it to the machine and we will train the machine. Okay, so from the given images the machine will learn, if the image is like this it's a tumor, if the image is like this it's not a tumor. Okay, so like that it will learn. Okay, so next time when you give a new MRI image of a new patient, okay, then it will immediately tell you whether the patient is having a brain tumor or not. Okay, something like that kind of applications are possible in medical diagnosis. Okay, then stock market trading, nowadays you can see a lot of advertisement like trading using AI. Okay, so how it is happening? All because of based upon the previous year's data. Okay, for example, in case the Infosys stock is there, okay, the price of the Infosys stock is now, for example, maybe 1,500. What will be the price of the Infosys stock after 5 years or 10 years? That kind of prediction we can do it. Okay, and you can buy that kind of stocks alone. Okay, so that is called stock market trading. Then online fraud detection. The online fraud detection like hacking. Okay, so there is some sequence of events which is followed by the hackers. So when there is some kind of events happening, then you can immediately identify it's an online fraud. Okay, then virtual personal assistant. Virtual personal assistant is the examples you can see real world examples. You have Alexa, Siri, then Google Home is there. No, you are talking to the Google, right? Hey Google, give me a answer for this, or give me what are the applications of ML, something like that. If you ask, then immediately it will give you the reply. Similarly, you can talk to Alexa. Alexa, what is the current news today? Then immediately it will give you the answer. So all because of the machine learning, because the Alexa or Google Home has been trained with a lot of voices. Even if I say hello, it will understand. If you say hello, it will be able to understand. Okay, how it is, because the foreigner will say hello in different modulation, and the Indians will say hello in different modulation. Okay, how the machine is able to identify? The machine is trained with lots and lots of different voices. Okay, it has been trained with thousands and lakhs of different voices, so that the machine will identify if you say hello in whatever the modulation. Okay, so that is the application in virtual personal assistant. Then we will have email spam and malware filtering. For example, in your Gmail you can see some of the mails automatically goes to what is that, spam folder. Okay, so how it is happening is all because of what is that, there is a algorithm available inside your Gmail. Okay, it's a machine learning algorithm. The algorithm will look for some keywords, for example something like some promotional keywords, some newsletter keywords. Okay, if you have this kind of information, immediately it will send that mail to the spam folder. Okay, so that is what email spam. Then self-driving cars, you can say Tesla. Okay, there is no driver available, uh, it the car itself drives. How? It has been fed with enormous amount of data. For example, if there is a red light, you will have to stop, you will have to apply the brake. If there is a speed limit of 40 kilometer, then you have to reduce the speed. All this kind of information has been already given to the machine, and it has been trained, and it has been fixed in the cars, self-driving cars, so that whenever it finds a red color, then it will stop. Okay, so that is an application. Then product recommendation, as you can see in Amazon, Flipkart, whatever. For example, one time you search for example laptop, next time when you go into the login, it will show you all kinds of laptops. Okay, and similarly, for example, one time you watch a thriller movie in the Netflix, if you log in again into Netflix, then next time it will show you all such kind of movies, thriller movies. Okay, so these are all some of the applications of ML. Okay, the product recommendations and traffic prediction. You know the Google Maps. Okay, so the maps will identify in what time the traffics will be heavy, and based on that it may suggest you some alternative routes also. Okay, then speech recognition, again it is related to virtual personal assistant. Okay, then image recognition, like you have a model called YOLO. Okay, you only look once. Okay, that is a famous model for image recognition that was developed by Google. It is able to identify almost all real world object, like table, chair, pen, paper, car, bus, animals, cat, dog, cow, whatever it is, what all mostly all kind of real objects it will identify. Okay, so how it is happening is all because of the model was already trained with enormous amount of images. Okay, so all kind of real world object images has been fed to the model, so that the model is trained, and then it will be able to identify easily the images, the objects, real world objects. Okay, so that is called real world image recognition. Okay, then automatic language translation, you can see some examples like Google Translator. Okay, so Google Translator is one of the best example. If you type something, automatically automatically the sentences will be translated into the language whatever you want. Okay, so this is also because of the model has been already trained with lots and lots of words. Okay, if you give this word, this is the translation. Like that, they may train the machine with lots of words and translated words. Okay, so with that, it is able to translate easily whenever you type something new on the Google Translator. Okay, so this is about some of the applications of ML. Okay, now with this introduction, I am moving on to a simple problem. That is a basic algorithm called linear regression. A linear regression in machine learning. Okay, so using this algorithm, this is one of the regression algorithm which comes under supervised learning. Using this algorithm, we are going to solve a problem called salary prediction. Okay, so for this you need a data set. Whenever you go for machine learning, you need a large data set. With the data set only you are able to train the model. Okay, now this is the data set we are going to use. Okay, it has only two columns. One is years of experience, the another one is salary. Okay, so years of experience is only the numbers like 1.1 year, 1.3, 2 years, and salary is given. For 3 years salary, the example for 3 years experience, the salary is something like this. Okay, so this data is going to be given to the machine and the machine will be trained. Next time when a new employee joins the company and he is having some 5.5 years experience, then the machine will immediately tell you the salary of the new employee. We can give this much salary to the new employee. Okay, so that is a problem. We are going to do it now. Okay, so what are the steps involved in this is, we are going to do first data pre-processing. That is, if you have any null values, wrong values, you can remove that. Then you will have to split the data set into training and testing data set. After splitting this, you will have to train the model. That is called fitting the simple linear regression to the training set. That is called training. Okay, then after doing the training, you can do the prediction. Okay, now let me go into the model. Okay, for this you need to load the data set. Okay, first of all I will go and load the data set now. Okay, so as usual, import these packages, necessary package numpy, matplot and pandas. Okay, and then you will have to use pd.read csv, and this is the data set file name, salary data. I will be loading this file now. Okay, the file name is salary data 1. Okay, so after loading this, you can try to execute this. You will be getting the same data whatever available in the Excel file. Okay, so this is my data set, and after loading the data set, the next your job is you need to split the data into x and y. Okay, here x is the independent variable, and y is called independent variable. Y is the dependent variable. dependent variable and x is the independent variable. Okay, so you need to identify this and you need to split this, then only you can proceed. Okay, so this is one of the important step. Okay, now what is dependent variable? Dependent variable is mostly the output. Okay, so what is the output here? Here the output is salary. Okay, because the salary is the one that you are going to find out. Okay, so salary depends upon the number of years of experience. Okay, so years of experience is independent, it is not depending on anything. Okay, salary only depending on experience. Okay, so this is column number 0 and this is column number 1. Okay, so with this we will move to the coding. Now I am trying to extract the independent variable, that is experience, into this variable x. Okay, so for that what you need to do is dataset dot iLocation. iLocation is index location, colon, there is no number before and after the colon. It means that I am going to extract all the rows. Okay, then there is something 0 given here. 0 is only 0th column I am going to extract. 0th column, all the rows I am going to extract. Okay, so now the experience, all the rows will come into this. Okay, then dataset dot index location, then colon, comma 1. Here I am going to extract only the column number 1. Okay, the column number 1 is salary. Okay, you can see here 0 is experience, salary is 1. So the column number 1 I am going to extract into the variable y. Okay, so that is the dependent variable. So y is always the dependent variable and x is the independent variable. Okay, now you can see the output, the x, print x, this is the output. I am having all experiences here. Okay, and the second output, print y. You can see y is this, all salaries will come into y. Okay, now x is separate and y is separate. Okay, now I am going to split this data set into training and testing. Okay, so for that you need to import this model from sklearn.model selection, import train test split. Okay, this function alone we can import, so that function will do the job. Okay, so what I am doing here, train test split x comma y comma test size equal to 0.2. so 0.2 is 20%. so 20% of the testing data is allotted for testing. Then what happens to the 80%? Automatically the 80% is assigned for training. Okay, so you specify only the test size, the other thing will be automatically assigned for training. Okay, next one, there is something called random state. Random state equal to 0. It means that if you have 1000 data, first 800 will be taken for training, the next 200 only, the last 200 only will be taken for testing. Okay, so if you give random state equal to 0, okay, so continuously 800 will be taken for training, next 200 will be taken for testing. If you give some other number, random state equal to some other number, then randomly 800 data will be taken for training and randomly 200 data will be taken for testing. Okay, it is something like that. Okay, so you can give numbers for random state, depends upon whatever you want to do. Okay, now so after this function, the x and y has been splitted into x training, x testing. So 80% of the training data is available in x and 20% is available in testing. And similarly y is splitted into training and testing. So x is splitted and y is also splitted now. Okay, the next one I am going to choose the model. I am going to select the model here. So since it is a regression problem, I am going for linear regression because we are going to do some calculation. Okay, so from sklearn dot linear model import linear regression. Okay, so this algorithm, this model you import, then you create an object for this model, regressor equal to linear regression. Okay, and after that you start doing the training. A regressor is an object, regressor dot fit, in bracket you supply the training data, x train and y train. Okay, so if you supply this data, then the training will happen automatically with the help of this function, fit function. So once after the training, you will get an output like this. So it shows the model is created. Okay, now after the creation of the model, I need to test the data, sorry, I need to test the model. Okay, so when you run this, first of all I will have to learn from the beginning, I will have to run from the beginning. Okay, so let me run all. Okay, now you can see you are going to supply the experience now. For example, for 10 years it's showing 1,19,000. For example, 5 years or 1 year. For 1 year the salary is 36,000. For 5 years experience 73,000. Okay, so like this you can give your own number and you can test the model. Okay, you can find out what is the salary that is going to be given to the new employee, whatever, whoever is joining now. Okay, and you can supply some testing data, a series of testing data like 10 data, 20 data, that also you can do it and you can test the model. Okay, so for that, one second. Okay, so this is the testing part actually. Y prediction equal to R1. Here the object name is given as R1. Okay, R1 equal to linear regression, R1 dot fit x train y train. So the model is trained now. After training the model, I think I need to load this data set. Okay, one second, let me load the data set. Okay. Now I will run all. The same coding, only this testing part I am showing here. Okay, so after training you will get this kind of box. Okay, so after getting this box, it shows that you have done the training properly, the training is over. Okay, then after this you can do the testing with the testing data, because you have splitted x train, x test train. So you are going to supply the testing data now and I am going to predict. Okay, so y prediction equal to R1 dot predict, give the supply the test data here. Now you print the test data and the predicted data. Okay, so this is the testing data. So what it shows, for 1.5 years experience, salary is 40,748. For 10.3 years experience, the salary is 1,22,000. Okay, so it goes like this. For 4.1, this one, and 3.9, this, 9.5, this one, 8.7, this one. Okay, so for each testing data, the predicted data is printed here. Okay, at the bottom. Okay, So that is how you can do the testing. After doing the testing, you can give your new values. For the new employee, you can give the experience, for example 2.5 years experience. What is the salary? 50,061. So like this you can predict. Okay, so this is what actually called as linear regression algorithm. Okay, so the steps are very simple. First load the packages, then read the data set. After reading the data set, you will have to split into dependent and independent variable, and after that you split it into training and testing data. Then you choose the model and train the model. After training the model, you test the model. After testing the model, then you can start doing the prediction here using some new values. Okay, so what is that dependent and independent variable is, you can understand from this graph. Okay, when you plot a graph between this dependent and independent variable, it has to come as a straight line. Okay, like this. Okay, so independent variable is in x, that is in x axis. Dependent variable is in y axis. Okay, so y equal to the formula is given here, mx plus c. It's something like a straight line equation. Okay, so where m is the slope of the line and c is the intercept, we will call it as usually. Okay, so y is the salary and x is the experience. Okay, so for each x, that is for each experience, I am going to plot the salary like this. For example, 1 year of experience, I'm going to plot like 10,000. Okay, for 2 years of experience, salary is 20,000. For 3 years of experience, 30,000. Like this, if you plot a graph, if you plot the points has to come in a straight line. Okay, if it comes in a straight line, then your model is perfect and your data are perfect, your model is perfect, you will get a good accuracy. Okay, but most of the time you will not get exact straight line, you will get a straight line like this. Okay, the points will be somewhere this side or that side of the straight line. Okay, so that is what happening in machine learning actually. You will not get 100% accuracy, you will get maximum 95 to 98, maybe 99 also. Okay, so 90 to 98 you will get the maximum accuracy, not more than that. Okay, so that's what maximum the machine learning models will do. Okay, so this is what actually called as linear regression algorithm. Okay, so let me stop with this, and we'll look at some more algorithms in the next session. Okay, maybe in the coming sessions. Okay, so let me stop with this. Thank you. Bye bye.